So today in class we did Chapter 7, Lessons 2 through 6, homework, review. Your job is to finish this worksheet, and if you want to check your work with this video, you may. For number 3 and 4, it says determine if the polygons are similar, explain the reasoning. And for number 3, we can see that side EM is 1, 2, 3, 4, 5, 6 units long, and EW is 3. So we have the ratio 6/3, which reduces to 2/1. And corresponding to that is HS or SH, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 for the units of that side, and SL 1, 2, 3, 4, 5. Well, 9/5 or 9/5 does not reduce to 2/1. So these are not similar. EWRM is not similar to SLGH. Number 4, we have side 7 corresponds to 14 due to the way we have 1 hash mark here and 2 here. 1 here, 2 here. So I'm using the values that fall in between those markings. That would reduce to 1/2. And then I'm going to use one of the other sides. How about the 8 in ratio to the 4, and that reduces to 2/1. And now the problem with this, which is really just a problem in how I wrote it, because I started with the 7/14, I really should have put the 4/8 to show that they are indeed similar 1/2 because of the same ratios. So for questions 5 and 6, we have each pair of polygons is similar. Find each missing side. In number 5, we're trying to find x. And because x is in between 1 dash mark and 3, we're looking to match it up with the corresponding side of 8. So x/8 equals another ratio, and we can pick any that we want. So let's do a nice number like 5 instead of the 3.5, and that's in between 2 dash marks and 3 dash marks. So that would correspond with the 20. So we have 5/20. So if we cross multiply and we solve, we get 40 equals 20x. And if we divide both sides by 20, we get x equaling 2. So this is 2 right here. We're going to do the same kind of thing for number 6. Solving for x here, x corresponds to the 18. So we have x/18 equals, and I'm going to pick the 3 corresponding to the 6. And I can also think of it this way. 6 times 3 will get me to my 18. So 3 times 3, the value for x would be 9. So x equals 9. For questions 7 and 8, the triangles are similar. We're going to write a proportion and solve the problem just like we did for 5 and 6. We're trying to find h, the height of this person, and compared to the height of the tree. And we have the distance, or I'm guessing probably they're talking about a shadow. And so the shadow of the person compared to the shadow of the tree. So we have 20h equals 125. If we divide both sides by 20, we get h equals 6.25. For number 8, I need to go back to number 7 and put my label on it. For number 8, we have the Gateway Arch in St. Louis, Missouri is 630 feet tall. 630 feet tall. And suppose a 12-foot tall pole is near and casts a shadow of 5 foot. So we're talking about how tall something is over the shadow. And they want to know that arc, how long is its shadow. So we have 12x equals 3,150. We're going to divide both sides by 12 to get x equals 262.5 feet. For 9 and 10, the last on the pages, we're going to do graph each pair of similar triangles and then write a proportion comparing the rise to the run for each of the similar slope triangles and find the numeric value. So we're at 1, comma 6 for R. S is 1, negative 6. T is negative 3, negative 6. You would use a straight edge because those are very poorly drawn. For me, without a straight edge or a tool to draw straight lines on here. And then we're changing colors to do negative 1, 0, which is U, negative 1, negative 3, which is V, and W, which is negative 2, negative 3, which is W. And so the slope is the rise over the run, and the rise from T to R is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So up 12 and over 1, 2, 3, 4. So I have 12 over 4 is the same as 3 over 1. For question number 10, we have triangle DEF with negative 6. Positive 5. We have E at negative 6, positive 2. And we have F at negative 2 and positive 2. So our triangle looks like this. Very poorly drawn. Have to really figure something out for that. And then we have triangle F, which is the same point, or they're sharing a point. Right here, negative 2, negative 4 for M, and positive 6, negative 4 for W. And so this triangle has this line that we're using the slope for, and we are going to write this as a proportion of the black triangle to the blue with a negative slope for both. And for the black, we have that we would go down 3 and over 4. And for the blue triangle, we would go down 2, 4, 6 and over 2, 4, 6, 8. And both of these actually reduce to the negative 3 over 4 to show that they have similar or constant rates of change for the rise over the run.